for section 1.4 notes, the first page is going to be review questions. I recommend that before you watch how to do them, you attempt each of the problems and then watch the video just to double check that you got the answers correct. So the first problem, hopefully you've tried this one already. This one, they want you to use the diagram to find the length of MW. That means we're looking for the part that's on the right side over here. Okay. This one, they have these two little dashes on each of the segments. That's telling us those segments are congruent to each other. To set up our equation, we are just going to put them equal. So 4x minus 1 equals 3x plus 3. Then we're able to solve the equation to figure out what our x value is, and that's what we're going to need to figure out what the length of MW would be. On this one, you would subtract 3x on both sides, then you could add 1 on both sides to get x equals 4. And we know the length of MW from the picture is 3x plus 3. What we're going to do is we're going to replace the x with a 4 because that's what we know it's equal to, and then we're going to solve. That gives us our answer that MW has the length of 15. So if you made any mistakes on that one, make sure you go and correct them. For number 2, they want us to draw a line AB. So when a line is named with 2 points like this, or 2 capital letters, each one represents their own point. So we're going to have point A, and then we're going to have point B. And it's intersecting plane G at point C. So we have a total of 3 points, A, B, and C. Then we have our plane, which is plane G. That's what we're going to draw first, our slanted rectangle, with a capital letter in one of the corners. Then the line is going to be intersecting the plane at point C. So somewhere on the plane, we'll put point C. And the line has a part going above the plane, below the plane, and then we have our hidden part. So that's the part where if we were to actually look at this in real life, we would not be able to see it, but we're drawing that to show that we understand that it's still there even though we won't be able to see that. And then anywhere on this line, we're going to add 2 extra points. They could be both on the top part or the bottom part, doesn't matter. And one's going to be labeled A and one's going to be labeled B. And with your pictures, every letter that shows up in the description should show up in your diagram. So we have A, B, C, and G, which means all of our labels are in the picture. Okay. Our next one, they're telling us that XY, that segment, has endpoints X at -5, -3, Y at -7, 7. They want us to find the length of XY to the nearest tenth of a unit. So for that one, it is going to be our distance formula. And that is when we do our difference in x squared plus our difference in y squared. Difference means we're subtracting, so we're going to take -5 minus -7 in parentheses squared plus -3 minus 7 in parentheses squared for our difference in y. Now you can simplify this, then type it into your calculator, or you can type it into your calculator now. This one did say to the nearest tenth, so that means we only have to go to 1 decimal point. And I'm going to change this double negative to a plus before I type it in. So we would have -5 plus 7 in parentheses squared plus -3 minus 7 in parentheses squared. Oh, that's not the squared button, sorry. There we go. So on your calculator, you should get 10.19803. In the directions, they said to the nearest tenth, so that's just 1 decimal point, making this about 10.2 for our answer. Our next one has segment XY as endpoints. X is at -2, -6. Y is at 210. They want us to find the midpoint. So for this one, we're going to use our midpoint formula. And that is when we start by adding our x's and then dividing by 2. So -2 plus 2 divided by 2. Then we would add our y's and divide that by 2. Negative 6 plus 10 divided by 2. Your answer is a coordinate point. So you're going to have an x value and a y value. It has to be in parentheses with the numbers separated by a comma. So for our x's, negative 2 plus 2, this part equals 0. 0 divided by 2 is 0. Then for our y's, negative 6 plus 10, that equals 4. 4 divided by 2 is 2. And that would be your answer for the midpoint. In parentheses, 0, 2. For question 5, they give us one endpoint G and the midpoint M of a segment. They want us to find the other endpoint F. For this one, we drew just a segment with 3 points on it. M is in the middle because it's the midpoint. Then we have G and F on the sides. G is at negative 1, 6. M is at 7, 3. We need to figure out the coordinate points for F. So we're going to figure out what is the change in x from negative 1 to 7. That would end up being plus 8. So we'll add that again. 7 plus 8 is going to be 15. Then we'll look at our y's. From 6 to 3, we are subtracting 3. And then we would subtract 3 again, which would bring us to 0. That makes our coordinate point for F 15, 0 for our final answer. Then the last part of the review is to determine if the following lines are perpendicular. Remember, the symbol for that is an upside down capital T. Or if they're parallel, which is those two lines next to each other, and we can use N for neither. So for letter A, it says the slope of line H is negative 3, and the slope of line G is negative 1/3. So they have the same sign, but the numbers are different. So that means it cannot be parallel. And then because they have the same sign, they cannot be perpendicular, because perpendicular slopes, you need one positive and one negative. So that means it's not parallel, not perpendicular, it would be neither. Okay, for part B, the slope of line T is 5 and the slope of line S is 5. Because the slopes are both positive and they're both 5, that means they are going to be parallel to each other. If you wanted an example of perpendicular, we could have a slope of 3 and a slope of negative 1/3. So because one's positive, one's negative, and they're the reciprocals, that would make this one perpendicular. So hopefully none of this information for the first page was new for you. This is all review from 1.1 to 1.3. The second page has all of the new information for today, and it shouldn't take very long to go through. On the second page, we're going to be doing something called algebraic proofs. And proofs are in a 2-column table like this one shown below, where one side is the statements that we're going to fill in and one side is the reasons. All of these words at the top with these bullet points, these are the reasons. Right now, our focus is just on algebraic proofs. We are going to do different types of proofs throughout the year, but for right now, we're just focusing on the algebra ones. To do algebraic proofs, you are basically solving equations, but you're just giving a reason why you're doing each of the steps, or a justification for each of the steps. So if we look at example 1, they want us to solve this equation using a table proof. Every time you start a table proof, you are going to start with the question they give you, or sometimes they'll label it as the given. That is going to be your first statement. So in this statement, we're going to write 2x plus 3 equals 9 minus x. And you have to write it there. You can't just circle the given and then put an arrow. That does not work. You have to write it in your table. Your reasoning for that is just your given, because it is the first thing they tell you in the problem. And you'll notice that is on the list of vocabulary at the top. So your given is always the first reason. Your proof should always start with given. Then if we look at our equation, the first thing that I would do to solve this one is get all of my variables onto one side. Now, the step where we are moving them, that is not the next statement. So I'm going to write it really small so I have room for the statement below it. So I would add x on both sides, and the result will be your next statement. And that would end up being 3x plus 3 equals 9. Now, if we look at our reasons in the list above, we added x to both sides. The one reason that looks similar to adding is the addition property of equality. So when you add something to both sides of an equation, that is when you're going to use the addition property of equality. So when you add to both sides of the equation. Writing down the reason addition property of equality for all of our different steps where we use that, that's going to be a lot. So we are going to abbreviate it, and that's just going to be the add prop of, and then an equal sign for equality. And every time you put this, you have to put property of equality with the reason, because we also are going to add different types of properties throughout the year. So we have to clarify the difference between them. So you have to put the whole property down. So add prop of equality. And we're going to put that for our reason in our next line. Then if we go back to our equation, the next thing, I would want to get all my constants on the same side. So the next thing I would do is I would subtract a 3. The result will be our next statement, 3x equals 6. And if we go and we look at all of our different reasons that we can use, one of them is subtraction property of equality. And we would use that when we subtract to both sides of the equation. And I'm not going to write that down. I'm just going to put an arrow down there. So subtraction property of equality is when you subtract to both sides of the equation. We're also going to abbreviate this one to SUBT, prop of equality. And again, you have to include the prop of equality to get credit for this. When you abbreviate subtraction, you also want to make sure you put the T with it. So SUBT for subtraction. The reason we have to add the T there is because there's also going to be a substitution property eventually, and that one is SUB. So we have to make sure there's a difference between our abbreviations. Then the last thing I would do on my equation to solve is to get the x by itself, so divide both sides by 3. And our result will be our last statement, where x is equal to 2. Looking at our different reasons at the top, there is one that is called division property of equality. And that one is when you divide both sides of the equation. So that's what we did, meaning we can use our division property of equality. And we're going to abbreviate this one as well, DIV for a division, and then we'll include prop of equality. And that is how you are going to set up an algebraic 2-column proof. And you'll notice we did not use all of the properties yet. Our next example will cover a couple more of them. Following the pattern of what we have seen with the different properties so far, multiplication property of equality, that is when you are going to multiply to both sides of the equation. to solve for your setup. So that one we would just abbreviate to MULT for multiplication and then put our prop of equality. And then we'll go over the last two reasons with our next proof. So I'll leave this here just in case you need to pause it and copy down any more information. And now we will do our last proof. So the very first thing that you always write down in your proof is what you're asked to solve or the given information. This equation we have 6 times in parentheses 6x plus 6 minus 5 equals 1 plus 6x. And again, our first reason every time we do a 2-column proof is going to be given. When you are doing these equations or these 2-column proofs, there are multiple different steps that you could follow to solve them. So the order that you solve the equation might be different than the person next to you, but as long as you're giving the right reason for each step, you can still get full credit. So the order I might solve this equation might be different than you, but as long as we get the same answer and you're using the correct reasons, you would get full credit even if your order was different. So if you're ever checking your answers and you did it a little bit different but got the same end result, you should be good. So on this equation, the first thing I would do is I would want to get rid of those parentheses. And the way that we would do that is by distributing. So you would have to multiply it by both parts in the parentheses. So 6 times 6x is 36x. 6 times 6 is 36. So that's the only thing that's changing. The rest of the equation stays the same. Now, we did multiply, but we did not multiply both sides of the equation. So we cannot use the multiplication property of equality. What we're going to use instead is just the distributive property of equality. So this one you are going to use when you distribute. And you usually distribute to get rid of parentheses. So that is when you're going to use the reason distributive property of equality. And we can abbreviate distributive to DIST and then our prop of equality. So now we can go ahead and add that to our reason on our table. DIST, distributive prop of equality. Now looking back at my equation, the next thing I would want to do is combine any like terms that are on the same side of the equal sign. So on this one, we are able to combine this 36 minus 5. So we'd still have 36x, and then those combine to 31, and it's still equal to 1 plus 6x. Now if we go back up to our reasons, we did subtract those numbers, but we didn't do it one on each side of the equation. We were just combining our like terms. So the reason you can give for that one is one of two things. You can either use simplify, or you can use combining like terms. Either one will get you the right answer. You do not have to put both. You just need one of them. The one that I use, and you'll see on answer keys, is just simplify. So distributive property is usually on one side of the equation to get rid of parentheses. Simplifying or combining like terms is when you're just combining things that are on, again, one side of the equal sign. So you're not adding or subtracting something to both sides. It's just on one. Okay. Now this looks very similar to our last problem. We want all of our variable terms to be on one side. So the next step I would do is I would subtract 6x. And that would bring us to 30x plus 31 equals 1. And that property we subtracted on both sides of the equal sign. So we are going to use the subtraction property of equality. Then I want all my constants on one side, so I'm going to subtract 31 on each side. And that's going to give us 30x equals negative 30. And it is okay to get negative numbers. Now for this one, you'll notice we used subtraction property for our previous reason, and we're using it again. If they are used right after each other, you still have to write two separate statements, but we don't have to write the reason again. You can just put an arrow, only if they're right next to each other like that. So you'll have two separate statements, but you can use the same reason multiple times. Then the last thing, I need to get rid of the 30, so I would divide both sides by 30. And that gives us our answer where x equals negative 1. And that was our division property of equality. In the question, they just wanted us to solve the equation. We got x by itself, but we did not use all of the boxes on the table. That's okay, we're just going to leave them blank. Sometimes you'll use them all, sometimes you won't. So it is okay to leave them blank if you don't need all of that space. All right, so if you have any questions on this, make sure you ask them at the beginning of next class. But you can go ahead and get started on the homework assignment so that you can get that done. And let me know if you have any questions. Have a